Hello class, and welcome back to section 8.2, part 2 of the notes video. We should be on the back side of the section 8.2 notes right now, and now we're going to get into adding and subtracting the rational expressions. Okay, so just remember from the example at the very front of your note sheet, to add or subtract rational expressions, you need to go ahead and have that common denominator. Okay, so that's what we're going to have to work on today, is getting that common denominator. So here's a quick little example. We would have 2 over 3 plus 3 over 5. And in order to add them together, I'd have to get a common denominator. So I'd have to multiply this by 5, because my common denominator would be 15, and this one by 3. So I would have 10 over 15 plus 9 over 15. And then I could go ahead, well, 10 plus 9 is 19 over 15, and so that would be my answer. Same idea here, but now we're going to be working with variables. Well, if I need to get a common multiple between c and d, well, I'd have to multiply this one by d. So if I do that to the denominator, I also need to do it to the numerator. And this one I'd have to multiply by c. Okay. So I would have a times d over c times d, and I just like to write them in alphabetical order. When it's multiplying, it doesn't matter. Then I'd have b times c over d times c is the same as cd. Then I would go ahead, since I have a common denominator, I can add my numerator. So I'm just going to write ad plus bc over cd. And there is my rational expression added together. Okay, so let's go ahead and look at some other examples like this. So I need to go ahead and I need to figure out, well, what will my common denominator be? And if you don't know, you can go ahead and break it down into the LCM like we did on the first half of the notes. So for instance, if I didn't know what number to get 15 and 18 to be, I can break down 15. It's really 3 times 5. And 18 is really 2 times 9, which breaks into 3 times 3. So my least common multiple between 15 and 18 would be, there's 1, 2, so it would be 2. There's 1, 3 here, there's 2 3s here, so times 3. And then there's 1, 5 here, no 5, so times 5. So the number I would get it would be 2 times 3 times 3 times 5, which gives me 90. And then I would go ahead and say, well, between y squared and xy, I'm going to for sure have an x, and then I would have a y squared. So this is my goal, to get my denominators to be 90 xy squared. So let's do that. In order to get 15 to 90, I would have to go ahead and multiply it by 6. And if you didn't know, you would just have to take 90 divided by 15. So I'd multiply by 6. And I need to have xy squared, so I have to multiply by 6x. If I do it to the denominator, I do it to the numerator. Over here, in order to get 18 to 90, I would take 90 divided by 18, and that would tell me I'd have to multiply by 5. And I need to have xy squared, so I'm going to have to multiply by 5y. Okay, so in my numerator, I would have 6 times 7, which will give me 42. X times x gives me x squared. Over 6 times 15 is 90 xy squared, plus 5 times 1, so I would just have 5, and then y times y is y squared. All over 18 times 5 is 90 xy squared. And now my denominators are exactly the same, so since they're the same, I can add my numerators together, and it's going to be over the denominator that stays exactly the same. So there's my answer for example 1. If I could combine what's in the numerator, I would, but I can't combine an x squared and a y squared. They're two different things. Okay, let's go ahead and look at example 9. Okay, same thing here. This one might be a little bit easier for us to think about. What number can I get 7 and 9 to both be? Well, that's going to be 63. So in order to get 9 to be 63, I'd have to multiply it by 7. And in order to get 7 to 63, I'd have to multiply by 9. And then I would have a b and a b squared. So I have to get both of them, my least common denominator in this case will be 63b squared. Okay, so I have to multiply this one by a b, so it's by 7b. So I'd multiply. 7 times 8 is 56. A times b will just be ab. Over 7 times 9 is 63. B times b is b squared. minus 1 times 9 is 9 over 7 times 9 is 63. AB squared. Sorry, I missed that. So I missed the A. So we have to have an A on there. So let's go ahead and actually change that. So in order to get an A, I have to multiply this one by A. So let's add that into there. So I'd have 56. A times A would be A squared, B, over 63 AB squared minus 9 over 63 AB squared. Now if I look, are my denominators exactly the same? Yes. So always make sure you're doing that check. Okay, that's how you're going to know if you're doing it right or not. My denominators are the same, so I can go ahead and just subtract my numerators. So my final answer will be 56 A squared B minus 9 all over 63 AB squared. And I can't factor anything out of here, so we are all done. There is example 9. Let's look at 10. Okay, this one. So my least common multiple for this one, or my least common denominator, either one, between my denominators would be 8. And then I would have to have an m squared and an n squared. Okay, so in order to make that happen, I already have the 8 and I have the m squared, so I'd have to multiply by n. And here I'd have to multiply by 8 and m, because I would have to have an m squared. So let's go ahead. I would have n times 1, it's n, over 8 times m squared. N times n would be n squared, plus 2 times 8 is 16m, over 8. M times m will give me m squared and then n squared. Once again, I check. Denominators are exactly the same, so I would have n plus 16m all over 8m squared n squared. There is my solution to example 10. Okay. Example 11 is a great time to go ahead and try example 11 on your own. And then after example 11, we're going to get into some problems where we need to do a little more factoring. Okay. So pause the video, try example 11, and then come on back. So my least common multiple for my denominators for this one, I have 3 and 5, so I can get them both to 15. And there's an x here, no x, so I'm going to have to get an x, and then they each have a y. Okay, so 3 times 5 will give me 15. And then I have xy, so we're good. So we multiply by 5 on these. And then to get to 15, I'd have to multiply by 3. But I need to have xy, so I have to multiply it by x. So I'd have 5 times 2 is 10. 5 times 3 is 15xy. Minus 3 times 3 is 9. X times x is x squared. All over 5 times 3 is 15xy. So now my denominators are the same. So I can go ahead and subtract my numerators. So it's 10 minus 9x squared over 15xy. And that's my final answer for example 11. Okay. For 12 through 15, we're going to be switching gears a little bit. So if you have any questions on 8 through 11, please write them down. And if you need to take a break, now would be a good time to take a break. All right. So we move on to example 12. This is where we have our polynomials. So we need to go ahead and factor. Okay, so I'm going to factor my denominator for example 12. So I can factor out of 4. So I would have w minus 4. And in this denominator, I can factor out a 2. So I would have w minus 4. So I would need to think about, well, what is my least common multiple for those denominators? So I have 2 and 4. So I would have 4 for sure. And then they each have a w minus 4. So my goal is to get my denominator to be 4 times w minus 4. Well, this one is 4 times w minus 4. This one's 2 times w minus 4. So I'd have to multiply this one by 2. Okay, so if I do that, I also have to make the numerator times 2. Biggest thing is it's everything in my numerator by 2. So I'm going to go ahead and write this. I would have w plus 12 all over, and I'm just going to write it as 4w minus 4. Minus, now I would have 2, so I would distribute this. Okay, so it would be 2w plus 8 over 2w minus 4. And now I go ahead, I would have 2 times 2, so this would be 4 now. Now that I have a common denominator, I can go ahead and put my numerators together. So I would have w plus 12 minus, now here's where we need to be careful, it's really w plus 8 all over 4 times w minus 4. Now I need to simplify a little bit more. I need to distribute that negative in my numerator, so it's minus 2w minus 8 all over 4 times w minus 4. I'm going to combine my like terms. So I would have w minus 2w, so it would give me negative w. 12 minus 8 will give me plus 4. All over 4 times w minus 4. And now I need to think, could I factor anything out to make this simplify? Well, if I take out a negative 1, I would have w minus 4 all over 4 times w minus 4. Then these would go ahead and cancel, and I would just be left with 1/4. Okay. So that would be my simplified answer for example 12. Okay, example 13, let's go ahead and take a look at that one. My left-hand side, let's factor the denominator first. This is a difference of perfect squares, so it would be x minus 2, x plus 2. So in order to have my denominators be exactly the same, this one has an x plus 2, so I would just need to add an x minus 2. Okay, so I would have 1 over x minus 2, x plus 2, plus x times x minus 2, all over x minus 2, x plus 2. Now here's where I need to go ahead and combine distribute and combine like terms. So I'm going to distribute this x, so I'd have 1 plus, I'm going to do it all in one, so I'd have x squared minus 2x all over x minus 2, x plus 2. I'm going to go ahead and rewrite, this is really x squared minus 2x plus 1 all over x minus 2, x plus 2. We should always go ahead and check, okay, what does this factor into? Well, to multiply to 1 times 1, but add to negative 2, those would both be negatives. Would anything cancel with my numerators and denominators here? No, it would not. So you can either leave it written like this, or you can leave the numerators factored. Either answer will be fine for me. But you should check to see if anything will cancel, because if this was x plus 2, then my denominators would cancel. But in this case, it is not. Okay, so you cannot do that. Okay. So there it is. There's my answer. Another answer that I would take is if you kept the denominator factored out as well. So if we went ahead and wrote this as x squared minus 4. Either one of those is perfectly fine. All right, example 14. Okay, here we go. We have to factor once again. So here, this one, I need to probably use the grouping, or you can use your guess and check method, but I'm going to do grouping. So I take 3 times 5, which gives me 15. So it's what multiplies to 15, but adds to 8. Okay, so that would be 3 times 5. So I would rewrite. So it's 3x squared plus 3x plus 5x plus 5. Then I group. I can take out a 3x, so I would have x plus 1. Here I can take out a 5, so x plus 1. So what's in parentheses is x plus 1, so I would have that, and then what's left is 3x plus 5. So this piece right here is x plus 1 times 3x plus 5. My other piece, I can factor out a 4, so I would have 3x plus 5. Okay, now I need to think, what do I need to add to each piece? Well, here, I would have to add a 4, so I'd have to multiply my numerator by 4 here, and now what I'm missing here is an x plus 1. Okay, so this is like side work that I have here off to the side. So now I'm going to simplify my numerators. So I would have 4x minus 4 just by distributing. And now you need to be careful because I have a negative out in front here. So I'm just going to say minus. And now if I were to FOIL x minus 1, x plus 1, that's a difference of perfect squares. So that's going to break down as 2x squared minus 1 if you were to FOIL all of it. all over, and my denominator will stay exactly the same. Okay, so we made it all be x plus 1, 3x plus 5. Now I go ahead and I'm going to distribute the negative here and combine like terms. So I have 4x minus 4 minus x squared plus 1 all over 4x plus 1, 3x plus 5 equals, let's go ahead and combine like terms. So I would have negative x squared plus 4x. Negative 4 plus 1 gives me negative 3 all over 4x plus 1, 3x plus 5. Now I would go ahead and check. Okay, in order to factor this, the numerator, I would take out a negative 1. So I would have x squared minus 4x plus 3 all over 4 times x plus 1 times 3x plus 5. And I would say if I could factor this, I would have negative 1. What multiplies to 3 but adds to negative 4? Well, negative 3 and negative 1. Denominator stays the same. And I check. Will anything cancel here? This is an x plus 1 and this is an x minus 1. So they will not cancel. So nothing will cancel. So this answer that I had up here, where it's all foiled out in the numerator, that will work perfectly fine. So you can write that down as your answer since nothing will cancel. And if you write this down too, then this would be equally as acceptable. Okay. We have one last example left, example 15. So if you have any questions, please write them down, but I would highly encourage you to pause the video and do example 15 on your own, and then come back and finish watching it. Okay, so first things first, we always factor. So what multiplies to negative 20, but adds to negative 1? Well, 5 times 4 will be 20. Negative 5 plus 4 would make it be negative 1. So I would think I have a plus 4, a minus 5. On my right-hand fraction, I have a plus 4, and I need to have an a minus 5 added on to that one. So my left hand, I do not need to add anything. So I would have a over a minus 5, a plus 4, plus, it's 2 times a, so I would have 2a minus 5 times 2, which will give me 10, minus 10, all over a minus 5, a plus 4. Now I'm going to go ahead and combine my numerators. So a plus 2a will give you 3a, plus a negative 10, so minus 10, all over, and you can write it as a minus 5, a plus 4. This is a good answer. Or you could write it as the factored form here. So 3a minus 10 over a squared minus a minus 20. Either one, and I got that just from up here. And the reason I know that this is my answer is I can't factor out a 3 and I can't factor out any a's, so either one of these answers would be completely acceptable. Okay, so that is how you are going to add and subtract rational expressions. If you have any questions, please write them down, come and ask me. Otherwise, have a great day, and I'll see you later.